Okay, so today we're going to start talking about logarithms, and this is what I've been referring to in some previous videos about how we can, or what we can use to find out what x is if x ends up being a exponent. So if I have an equation like this, AD equals 10 to the x power, and I want to figure out what exponent of 10, or what exponent applied to 10 would give me 80 as my answer, approximately 80, because it wouldn't work out perfectly in this case. I could use logarithms to find this out. Now, let's look at some things here. Now, what I'm going to do is, I'll do my best. Logarithms, once you get the idea of logarithms, they're a very basic, very easy concept, but they're foreign. It's something new. It's something that you've never learned before, so it's real easy when we're exposed to something new to get frustrated, to just want to give up because you've never seen it before and you don't understand it right at the beginning. But please don't do that. Logarithms do not have to be that difficult. They are not something that are meant to be challenging. They're really a very basic, easy concept. So if you pay attention, I'll go through these notes and I'll try to summarize them, but I can't really summarize it very easily until I've gone through some of the basics here. So first, let's consider this equation, x equals b to the y power, when b equals 10. And if that's the case, then we would have x equals 10 to the y power. So we say that y is the logarithm of x to the base 10. Because the key here to know, and I'm going to do a little bit of jumping around here, is that logarithms are essentially exponents. So this paragraph here, let's actually start here. So you may want to just pause this video and write down this paragraph that I just highlighted. But it says logarithms are exponents. That's what I was just referring to in that previous sentence. We'll go back to it in a minute. The logarithm of x is the exponent to which the base is raised to get x. Logarithms to the base 10 are called common logarithms, or common logs. We often write common logs without indicating the base. That is, log x means the same as log base 10 of x. So let's go back up here again now that we understand or know what, or defined what a logarithm is. Remember back in the beginning of the chapter, we also talked about a very basic concept, and that's if we have a to the b power, we have the exponent. And remember what we call this? We call this the base. So whatever number or letter or variable, whatever it is sitting on the ground, we call that the base. Well, the base that we referred to here is referring to the same base that we talked to at the beginning of the chapter. So here's the definition of a logarithm of x to the base 10. It's written like this. But here's a couple ways we could say this, what I just wrote down. You could say the logarithm of x to the base 10. That's one way to say the phrase that one way to phrase what I just wrote down. You could say log of x to the base 10, or log base 10 of x. And that's usually the way I phrase it, just because. But again, any three of these ways of phrasing it would work. So I always say log base 10 of x equals y in this case. Now, we can write this in exponential form, where your base is 10. Remember, your exponents are always what the logarithm equals. That's what logarithms are. Logarithms are equals, or logarithms are exponents. So y, what the log base 10 of x equals, is your exponent. So 10 to the y power equals x. Now, why is this important? There's going to be situations where we're going to have something written in logarithm form, and we're going to have to rewrite it in what we call exponential form. That's what this is. Or there'll be times when something's written in exponential form and we need to write it in logarithm form to be able to solve it. And you'll see what I mean when we get to different examples. But let's go back to what I had written here. The log base 10 of x equals y. Remember, your base is 10, and that's what our base is over here. Your exponent is what a logarithm equals. Which is what we have over here. So that's what's important to know about logarithms. So hopefully we'll look at some examples here, and hopefully it'll start to come together for you. So as far as transferring between logarithm form and exponential form, that's what this table is doing here. If I have 10 to the 7th power, that's the same as 10 million. Or I could say the log base 10 of 10 million equals 7. Because remember, this is your base, is 10. Your exponent is 7. So the log base 10 of your answer here, the 10 million, would give you your exponent, which is 7. So let's say if I didn't know, if I had 10 to some exponent would give me 0.001, I could do this on my calculator by taking the logarithm of base 10, because that's what my base is here, of my answer, which is 0.001. If I did this on if I type this in my calculator, because we do have logarithm buttons on our scientific calculators, you would get -3 as your answer, telling me that 10 to the -3rd power would give me 0.001. So all of these are true. If we have 10 to the 1/2 power, that's the same as the square root of 10. So log base 10 of the square root of 10 would end up giving me 1/2. 10 to the -1/4 power is the same as 1 divided by the 4th root of 10. Or we have log base 10 of 1 over the 4th root of 10. If you did that on your calculator, you get -1/4. So this summarizes what we're talking about here, this last row. That 10 to the a power will give you b. So if you have something in exponential form, that's how we would write it. 10 to some exponent would equal b. Or, as in logarithm form, you'd have log base 10 of b equals a. Again, this is your base. Oops. And this is your base. A is your exponent. And that's written over here when we write it in logarithm form. Okay. We're going to do these without a calculator. Now the way that we're going to do these, and again, common logarithms, just to go back over this last sentence, common logarithms is what we're focusing on today. That's when we have always a base 10. Now when you're writing things in base 10, or common logarithms, you don't need to include the base. So when I have something written like this, that means that I have a base of 10, we just don't need to include it. So in other words, here we have the log base 10 of 100. So in other words, I'm trying to figure out 10 to what exponent would give me 100. Well, you might know that 10 squared would give me 100, so that means that log base 10 of 100, or log of 100, is equal to 2. Because remember, take the logarithm of a number, finds our exponent. So our exponent would equal 2 here. Log base 10 of 100 would equal 2. Now, if you didn't know, like let's say log of 10,000, I'm going to the one below it here. If you didn't know the answer, here's an easy way to get to it. We're going to count the number of decimal places not zeros. Oops, can't spell. We're going to count the number of decimal places, not zeros. The decimal is moved to get to 1. In other words, going back to the part A here, here's my decimal. If I move the decimal place 2 places to the left, it's going to be 2. So my log, common log of 100 would equal 2. So here, an easy way to do it, I'd move a decimal place 4 places to get to 1. So my answer here would simply be 4. Because 10 to the 4th power, sure enough, is 10,000. Now let's say if I have log of 1, I'm skipping B and E for now, if you notice. But if I have log of 1, how many places do I move the decimal to get to 1? 0 places. So that means this is 0. So in other words, 10 to the 0 power is 1. And that goes back to that theorem that we talked about back in chapter 7, the zero exponent theorem. Anything raised to the 0 power is always going to be 1, so log of 1 is always going to be 0. For this one, log of 10 is going to be 1, because I would move the decimal place one place to the left, or 10 to the first power would give me 10. Now what if there's already a decimal? We use the same rule that we just talked about, where we're going to count the number of decimal places, not zeros, to get to 1. Because here, if I move the decimal place 1, 2, 3, 4, that's not 1. I have to move it 1 over to get to 1 whole. So if I stopped at 4, I'd be at 0.1. So again, I move the decimal over 1, 2, 3, 4, 5 places to get to 1. But I moved it to the right. So my answer in this case is going to be a negative. Just like in scientific notation, when you move the decimal to the right, it's negative. When you move it to the left, it's positive. So this is going to be, because 10 to the negative 5th would be 0.0001, my answer would be negative 5. So here you move the decimal place over 3 places to the right to get to 1 whole. So that means your answer would be negative 3. Now these, I just want to make sure that you know how to use your calculator. We're not going to do all of these. We'll just do the first 2. So if you get your calculator out, just go to a regular calculator screen. The first one asks you to take the logarithm of square root of 2. Now on your CAS calculator, your logarithm is down here to the left of 1. It's in blue. So you're going to hit Control and then 10 to the x to get access to log. Now the nice thing about this calculator is you can change the base. Now you can put base 10 if you want, and then arrow over or tab over to get to what we want to take the logarithm of. We're going to take the logarithm of the square root of 2. So square root of 2 equals, and they ask you to round to the nearest 100,000th. 100,000th would be 5 numbers after the decimal. So I look to the right of 1 to see if I round that up, and it's a 4, so I'm going to leave it the same. So my answer is 0.15051. Let's try one more, logarithm of 5. Now this time, I'm going to have you just type in, Control 10 to the x, there we go. Instead of base 10, I'm not going to put anything there because remember this is a common logarithm. So if I just take the logarithm of 5, now when I hit enter, watch what happens. The nice thing about my calculator is it'll automatically show you what it just did to make sure that it did what you wanted it to. And that is to have it as a common logarithm or a logarithm of base 10. And that is what we wanted, so our answer, again, if we round it to 5 numbers after the decimal place, would be 0.69897. And 69897 would be your answer. Let's look at another type of problem you might see in your assignment today. Here it says, between which 2 consecutive integers is a logarithm of 5,673? Again, we're trying to figure out, this is a base 10. I'm trying to figure out what exponent I'd apply to 10 that would give me close to 5,673. This is one we would do without our calculator. Because here's what I know. I know 10 squared, well that's 100. I know 10 cubed is 1,000. I know 10 to the 4th would be 10,000. I could keep going, but the idea here is to figure out between which 2 consecutive integers, between which 2 numbers is going to be our answer. Remember, we're looking for between which 2 exponents would give us 5,673 when we apply them to 10. So 10 cubed is 1,000, 10 to the 4th is 10,000, so 5,673 falls between 1,000 and 10,000. So your answer is going to be, what exponents gave us those? Well, it'll be between 3 and 4. So if you did this on your calculator, you would get a decimal between 3 and 4 that would give you log base 10 of 5,673. So if I were to continue that out, if 10 to the 4th is 10,000, then 10 to the 5th would be 100,000. So 75,981 is between these 2 numbers, between 10,000 and 100,000. So that means the logarithms that this would be between would be 4 and 5. So in other words, if I type log of 75,981 in my calculator, I'd get 4 point some number as my answer. Now, the majority of your problems will be ones like this. And these are ones where, yes, you could use your calculator because we're trying to solve for x. Right now, these are put in logarithm form. I can't take log of x and type that in my calculator. Won't know what to do. So we're going to change these to be in exponential form. So if you're ever stuck and if you don't know what to do, and if it's in logarithm form, try changing it to exponential form to see if that helps you get unstuck. So remember, this is a base 10. So my base is 10. My exponent is 1/2, and that's going to equal my value for x. And sure enough, I can do this on my calculator. 10 to the 1/2 power would end up being approximately 3.162. Let's try another one together. Where we have a decimal. Here we have common log of x, or log base 10 of x equals 0.71. So my base here is 10. My exponent is 0.71. And do that on your calculator. 10 to the 0.71 power is approximately 5.129. And that would be your answer. Why don't you take a second to do this for parts C and D. So why don't you pause the video and hit play when you're ready to check your answer. Okay, so for this one, you should have taken 10 to the 3/4 power, because a base common logarithm is, so you has a base 10. Your exponent is 3/4. Do this on your calculator, you get 5.623 approximately. This, you take 10 to the 1.5 power, which would give you approximately 31.623. Now, changing something between a logarithm form and exponential form works because these are inverses of each other. So here, if you were to graph y equals 10 to the x, you would get this graph here, because this would be an exponential growth. If you were to graph y equals log of x, this is a graph you'd get. Now, if you notice, here's the line y equals x. Remember, logarithms are inverses are reflections over that line y equals x. So that's how we can see that these two are inverses of each other. So there's some things that are important to notice about these. When you have something in the form y equals 10 to the x, it's always got a domain of the set of all real numbers and a range of the set of all positive real numbers, because it's greater than 0. When it's in that form, y equals 10 to the x power, so when it's in exponential form, it's got an asymptote. That's the x-axis, or the line y equals 0. And its y-intercept is always going to be where y is 1 and x is 0. When we have something, the same thing in logarithm form, so the inverse of that, remember what we talked about with inverses, is that the domain is going to be switch with the range. So now the inverse, y equals log of x, is going to have a domain of the set of all positive real numbers and a range of all real numbers. So that means asymptotes are going to flip. So instead of having an asymptote of the y-axis, you can see from your graph here that you're going to have an asymptote of the y-axis instead of the x-axis, or where x equals 0. And instead of having a y-intercept of 1, these always have an x-intercept of 1. So those are some important things to notice. So again, just to reiterate kind of the main idea here for this lesson, is to know that if we have something in logarithm form, and you can't solve it, put it in exponential form. So this, to solve this, we would take base 10 to the 12th power, and that'll give us x, which you could do on your calculator. It would be 1 followed by 12 zeros, 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 So this would be your answer. Or if we have something in exponential form, like let's say if I had 80 equals 10 to the x power. And I don't know how to find out what x is here. I can put this in logarithm form. So it would be the log base 10, that's what my base is, of x equals, I'm sorry, I wrote that down wrong. Log base 10 of 80 equals your exponent, which is what we're trying to find. So type that in your calculator and you get your answer. So that's the difference between logarithm form and exponential form. They can be used interchangeably. So again, this is kind of a foreign concept, but hopefully after watching this video you'll have at least a beginning understanding, and maybe after doing the assignment you'll understand better how to use logarithms. So with that, good luck.